Alright, so this next video is just going to be a quick example of a problem that you might be given. And the question, which actually this is from the last video, let me erase this. The question is straight out of my notes, but I'm just going to talk through it, and that is to find a second degree polynomial f of x so that f of 1 is 4, f prime of 1 is 1, and f double prime of 1 is 4, aka it gives you the x value for the normal function, the derivative, and the double derivative, which is the derivative of the derivative. And you have to use this to find out what the original function was. This might sound confusing, but let me just point out the important things to know from this problem. Second degree polynomial. And I'll put the question in the description. And then I'll write down the information that we got. F of 1 equals 4. F prime of 1 equals 1, and f double prime of 1 equals 4. Now, I wrote these down because it's the information given, but I wrote this down because it's important to note, if the second degree polynomial is the original function, it means that the highest power is just something squared. Now, the reason this is important is because think about it. Because of the power rule that we talked about last video, every derivative, the main power is going to go down by 1. And for this reason, if this one is x squared, something with the second degree, then this one, the highest power must be just x to the 1. Then that must mean that this last one right here is just going to be some constant because it's x to the 0, which is just 1. For this reason, we can go ahead and assume that f of double prime of x equals 4. Why can I write this? Because no matter what we know that there must not be an x in this f double prime equation, and so whatever x you put in, you're always going to get 4, because that's what the information was given. So now let's think about this and go, well, backwards. If we're going to do kind of like a reverse power series here, or power, excuse me, not power series, power rule, then let's go ahead and just give it some variables. F prime of x must be, well, 4x. Why? Because if you take the derivative of this, pull the 1 down, then you're left with 4, which is what we're going to want. So, because we're kind of going backwards. This is a process called integrating, which is like with integrals, and we'll be doing this tons more later, but just try to follow me now. And then think about also that there has to be some constant tied onto the back of this. Why does there have to be a constant tied onto the back of this? Because without this constant, the derivative of it would just be 0. So for all we know, there's some extra number here that just disappeared when you took the double derivative. And so then we can go ahead and do this again and get f of x equals 4, and then I'm going to go ahead and put an ax squared. The power went up because we're the power rule. A is just basically saying that there's some thing, I can't talk, there is some coefficient that could be here that cancels out another coefficient. Basically, there could be, is what my point is. And then we'll do b, but now we have to multiply it by x because this was a constant similar to before, so we have to add a variable, plus another constant because of the reason we said before. Now it's time to plug in, knowing the knowledge that we have, plug in what we got and see if we can find out what a, b, and c are. Forgot to put the... Okay, so if f prime of 1 is 1, then 1 equals... Wait, I'm sorry, actually, I don't know why I put that a there. 1 equals 4, because you plug in 1, plus b equals -3. So therefore, we can then replace this b with a -3. Then, lastly, we know that b is -3, so I can actually go ahead and make this right here minus 3x. I don't know why I keep... Oh, I'm sorry, I just realized something. This right here, I'm sorry if I didn't correct this early in the video, is actually 2. And the reason is because you're going to pull down this exponent and it's going to turn into 4, so you have to have this as 2. I probably should have fixed this. I'll put an annotation or something, but so now we got this. So now we have this last one, which we need to solve for, and then we'll have our answer, because we just want to know what this is. So, well, we know that f1 equals 4, so 4 equals 2 times 1 squared, which is 1, minus 3 times 1, which is just 3, plus c. C equals 5. So therefore, our final answer is 2x squared minus 3x plus 5. I very, 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 very much hope that you understand that.